This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at inverse trig functions, integration. And we got integrals involving inverse trig functions. Let u be a differential function of x, and let a be greater than 0. Excuse me. The integral of 1 over square root of a squared minus u squared du is equal to arc sine u over a plus c. And the integral of 1 over a squared plus u squared du is equal to 1 over a arctangent u over a plus c. And the integral of 1 over u times the square root of u squared minus a squared is equal to 1 over a arcsecant absolute value of u over a plus c. So let's take a look at our first problem here. So we got the integral of 1 over the square root of 1 minus 9x squared. The instructions find an indefinite integral. Come back over to here. We got two possibilities. Our first formula has a square root in it. The second one has a square root down in the denominator. Or third one, I mean. The second one doesn't have it. So it's either going to be the first one or second one. Now specifically, this one would have something before the square root. And I don't have anything before the square root. And not only that, but this is a squared minus. A squared means you got a number before your minus. Well, we got a 1 before the minus. So I'm going to try to get it to fit this form here. So I want to rewrite this as a squared. So I want it as something squared minus u squared, like that. Well, 1 we can rewrite. 1 times 1 gives you 1. And 9x squared, that'd be 3x. 3x times 3x gives you 9x squared. Well, a would be 1. U would be 3x. Du would be 3 dx. We take the derivative of 3x, gives us 3, and then we put on our dx. Well, the a we have. The u is accounted for. The 3 dx, well, we have the dx, but we don't have the 3. So we need to put a 3 in there. And I'll offset it with a 1/3 out in front. Because if you put a number inside, you have to offset it with the reciprocal out in front. There we go. So now this is accounted for. This is accounted for. And 3 dx. 3 dx. So everything's accounted for. So this will become 1/3 the integral. Replace 3 dx with du. Replace the 1 with a, so it becomes a squared minus, and replace the 3x with u, so it becomes u squared. Which matches our formula perfectly. So we're going to rewrite it as arc sine u over a plus c. So we got 1/3 arc sine u over a plus c. Well, u was 3x, so plug that back in. Over a was 1 plus c, which ends up giving us 1/3 arc sine of 3x plus c. And that's our answer. Go ahead and work my second problem here. We got 1 over 2 plus x minus 4 squared dx. If I come over here, try to match up against one of these formulas, first one and third one have square roots in them. I don't have a square root. So I'm going to try to rewrite it as the second one. So we want a squared plus u squared in denominator. Well, I can rewrite this as something squared plus, and this is already squared, so that works out very well. Very well. Works out well. Now the 2 we can rewrite as the square root of 2 to the second power. Because going backwards, the square root and the second power cancel each other and just leave you the 2 dx. So a is going to equal square root of 2. U is going to equal to x minus 4. And du, the derivative of x minus 4 is 1. So we got 1 dx or just dx. And the a is accounted for. This is going to be u, so that's accounted for. And then our dx. So everything's accounted for in our problem. So this is going to become 1 over, I replace the square root of 2 with a, so we've got 1 over a squared plus, and I replace the x minus 4 with u, so that's u squared, and dx I replace with du. And now this matches our formula exactly. Du you can have up on top or to the side, it doesn't matter. But it becomes 1 over a arc tangent of u over a plus c. Well, a was square root of 2. Arctangent u, which is x minus 4 over square root of, or a, which is square root of 2, and then plus c. Now I don't know if they actually get rid of the square root downstairs in this particular textbook, but you could multiply the top and bottom of the fraction by a square root of 2 to get rid of it. Okay, let's look at our next problem. Number 3. We've got the integral of 1 over 3x square root of x to the 4th minus 9 dx. Now as we look at our formulas, we have a square root down in the denominator, so it has to be the first one or third one. Specifically, we have something out in front of our radical, so we're going to try to go with the third one. Now it doesn't always mean it'll work. Sometimes just the way you do your U-substitution, what's in front of the radical will disappear, but you should, just try that to begin with. And specifically, see before the minus we have an x to the 4th. This one is where you have a number before the minus, so it's going to be this one. Okay, so we've got 1 over 3x, and I'm going to try to write this as something squared minus something else squared. Well, the x to the 4th I can rewrite as x to the 2nd power squared, and the 9 I can rewrite as 3 squared. Okay. Well, this would be our u, and this would be our a, so a is going to be 3. U will be x squared. And then that would be accounted for with that. Now if I take the derivative of that, derivative of x squared gives us 2x dx. Now I seem to be missing some items here. First off, let's see what's accounted for. That's going to replace that. This is going to replace that. And dx, okay. Well, to begin with, we got an extra 3 down in the denominator, so I want to go ahead and throw it out in front. Okay. So then we got x, and then the square root of x squared squared minus 3 squared, like that. Okay, so that would get rid of that. But what we need is we need a 2 up on top. We also need an x up on top. So let's see about handling that. Well, I'll put a 2x up on top. Now the number, if I put 2 up on top, I have to offset it with a reciprocal out in front. So I'll put a 1/2 out in front. Now this x just carries along. Now I put an x up on top also. Well, if I put an x here, I have to put an x down here. You can't put an x out in front. So if you put an extra variable up on top, you have to put the same thing on the bottom. If it's going backwards, the x's would cancel. And then this gives us x squared squared minus 3 squared dx. Okay, well, it's starting to look better. Let me simplify this a little bit. 1/3 times 1/2 is 1/6. And I got 2x over x squared square root of x squared squared minus 3 squared dx. Okay, well, let's see what's going on here. Okay, that's accounted for. X squared. Well, that's accounted for, and this is an x squared also, so that's accounted for. 2x dx. 2x dx. That's accounted for. So everything's accounted for inside my parentheses. So this is going to become 1/6, and this x squared right here I'll replace with u. Square root, and I'll replace this x squared with u, so it becomes u squared minus, and I replace the 3 with a, so that's a squared over 1, and 2x dx gets replaced by du. And now it matches our formula exactly. So we got 1/6 carries down, and then the formula says 1 over a arc secant the absolute value of u over a plus c. Well, let's plug things in. A we said was 3, and u was x squared, so we got the absolute value of x squared over a, which is 3, plus c. Well, that gives us 1/18 arc secant. Now think what x squared does. When you square something, it automatically becomes positive. If you had -2 squared, it gives you a positive 4. If you have a 2 squared, it gives you a positive 4. So the absolute value bars aren't necessary there. So this becomes x squared over 3 plus c. And that's our answer. Let me go ahead and save this page. Inverse trig functions integration. Trig functions integration. Page 01.pdf. There we go. And let's look at our next problem. Number 4. Got the integral of 4 over x square root of 5 minus natural log of x squared dx. Okay, let's go up and look at our formulas. We got a square root down in the denominator. Makes me think it's either going to be the first one or third one. Now I have a variable out in front of the square root, which makes me think it should be this last one, but notice there's a number before the minus. So that's going to get me to thinking that it's the first one. So let's try to rewrite this as something squared minus something squared. Either formula, you have to do that. Okay, well, this will be 4 over x, and then the square root of 5 squared minus natural log of x squared. So we got something squared minus something else squared. Well, the what's inside the first parentheses will be our a, so a is square root of 5, and u would be what's inside our second parentheses. Now the derivative of natural log of x is 1 over x dx, which works out well because I have an x down in the denominator. The only thing I have is I got an extra 4, so I'm going to throw that out in front. And this becomes 1 over x square root of the square root of 5 squared minus natural log of x squared dx. Okay, so let's see what's accounted for. Square root of 5, square root of 5. Natural log of x, natural log of x. 1 over x, 1 over x. Dx, dx. So everything's accounted for. So we can go ahead and do our substitution. So we'll have the square root, replace the square root of 5 with a, so it becomes a squared minus, and replace natural log of x with u, so it becomes u squared. And 1 over x dx gets replaced by du. Well, this matches our formula exactly, the first one. So that becomes 4 arc sine of u over a plus c. Well, now let's plug that back in. What did we say u was? U was natural log of x over a, and a was square root of 5 plus c. Now I can multiply top and bottom by square root of 5 to get rid of that down below. Some books do that, some don't. Be nice if there was some kind of consistency in textbooks, but okay, let's look at our fifth example. Got the integral of cosine x over 3 plus sine squared. Now let's go back up to our formulas. There's no square root downstairs, is there? So it can't be the first one, can't be the third one. So let's try to write this as something squared plus something squared. Okay, so we got cosine over the square root of 3 squared plus sine x squared. Well, a would be square root of 3, u would be sine x, and then we'd have a squared plus u squared, which is what we're wanting. Now du, the derivative of sine is cosine x, and then we have to throw on a dx, which works out really nice because that's what I have up on top. So that's going to replace that. Sine x, cosine x, dx, dx. So everything's accounted for in my my problem here. So I'll replace the square root of 3 with a, so that becomes a squared, plus I replace sine with u, so that's u squared, and cosine x dx I replace with du. Matches our formula exactly, so that becomes 1 over a arc tangent of u over a plus c. Well, a was square root of 3, so we'll have 1 over square root of 3 arc tangent u, which was sine x, over a, which was square root of 3 plus c. And that's our answer. Do I have room for this one? I'm not sure if I have room or not. Let me save this page, and then we'll start a new one. Okay, did I save it? $8 p.m. Yes, it did. Okay. It's kind of weird how that window popped up right then. Made me wonder. It's like, so we're going to have the integral of x to the fourth minus 9 over x squared plus 3 dx. Well, if I go back to my formulas, of course, don't have no square root downstairs, so it can't be the first one or third one. It has to be this one. and this would be easy to rewrite as a squared plus u squared. I'd have to flip these around. But then I got a bunch of extra junk up on top that I wouldn't know how to account for. Now notice that the degree of the top is 4, degree of the bottom is 2. When your degree of the top is greater than or equal to the bottom, then you can use long division on these. Now you can also factor this particular one and make it even easier. Actually, let's go ahead and do that, because I'll show some long division and some of these other ones. Top one is the difference 2 squares, and it factors as x squared plus 3 times x squared minus 3 over x squared plus 3 dx. Now after I factor the top part, you see they both have an x squared plus 3, so those are going to cancel. And we have the integral of x squared minus 3 dx. And now there is no u-substitution. We don't have to use the methods of this section. Just add 1 to your power, divide by your power. So that becomes 1/3 x to the third minus 3, we just put an x on it, plus c. And that's our answer. Again, what made me think this is because the degree at the top was greater than or equal to the bottom. I always think long division, or in this case you could factor it, which I didn't see at first. Let's take a look at this one. Got the integral of 5. I guess that one was pretty short, wasn't it? I could have done that on the last page. And then 2 plus x. And I forgot something. I forgot my dx. And let's go look at our formulas. Assuming we're going to use these formulas, and I don't really see any other method available. There's no square roots. Can't be the first one, can't be the third one, has to be this one. Now I want a squared plus u squared. Well, I can rewrite what's inside here as something squared plus something squared. So this becomes 5 over square root of x, and I'll rewrite this as a square root of 2 squared plus, and I'll rewrite that as a square root of x squared. If it's going backwards, if the square root and the second power would cancel, and I'd end up with 2, and here I'd end up with x. Okay, so this is going to be our a, this is going to be our u. Let me go ahead and write that down. A is equal to square root of 2, u is equal to square root of x, which is also x to the 1/2. Now du. The derivative of x to the 1/2, you take your 1/2, put it out in front, lower your power by 1, dx. Which then, take the x to the negative 1/2 downstairs, it becomes x to the positive 1/2. When you take something opposite in a fraction, the sign of the exponent changes. And that's the same as 1 over 2 square root of x dx. That's what x to the 1/2 means. Which works out pretty good because I have a square root of x down there. So let's see what's accounted for. That's going to be replaced by a, so we're good there. This is going to be replaced by u, so we're good there. Our du. We have the dx. We have the square root of x downstairs, but we don't have a 2 down there. So we need to get it there. First off, we got an extra 5 up on top. I'm going to throw it out in front. And I'm going to put a 2 down below. Okay. Now when I put a 2 down below, that's the same as 1/2. So I have to put a 2 out in front to offset it. 2 times 1/2 would cancel away. Okay, so now 1 over 2 square root of x, 1 over 2 square root of x dx. So all that's counted for. This is going to be replaced by a, and this will be replaced by u. So what we have then, 5 times 2 is 10. 1 over, that gets replaced by a, so we got a squared, plus, that's replaced by u, so we get u squared. And 1 over 2 square root of x dx all gets replaced by du. Which works out well because it matches our formula exactly, the second one. So 10 carries down times 1 over a arctangent u over a plus c. Now a, what did we say a was? A was square root of 2, so we got 1 over square root of 2. Arctangent u, which was, scroll up a little bit, u is square root of x, over a, which was square root of 2, plus c. Which ends up giving us 10 over square root of 2, arctangent, square root of x over square root of 2 plus c. And you could multiply top and bottom by square root of 2 if you wanted to get rid of that, but I don't think the book probably does that. Famous last words. What problem was that? That was number 7. So let's take a look at our next one. Let me grab a drink here. So we got the integral of 5x minus 1 over the square root of 1 minus x squared dx. Okay, let's go look at our formula, see what we're dealing with, what we have to work with. Square root down denominator. Square root down denominator. So it's either the first one or third one. Specifically, there's a number in front of the minus. So that'd be the a squared minus. So it's the top one. But we got a problem here. We got some extra junk up on top. Well, how about if we set the what's inside the square root equal to u? Let's see what that gives us. Now just kind of do it over here on the side. We got u is equal to 1 minus x squared du would give us negative 2x dx. Well, we have an x up on top, so that might work, except for it doesn't really look like negative 2x, does it? But we can split this up into separate integrals. Got two terms up on top. You can split them up in this manner. So now if I did my u-substitution here on the first one, we got u is equal to 1 minus x squared du would be negative 2x dx. I can see, well, it's pretty close. I got an extra 5. I need a negative 2 there. So first off, let's take the 5, throw it out in front. What I really need inside is a negative 2, so I'll put it there. And to offset that negative 2, then we'll put a negative 1/2 out in front. Because a negative times a negative is positive, and 1/2 times 2 gives us 1. And now, let's see what's accounted for. 1 minus x squared, 1 minus x squared. Negative 2x dx, negative 2x dx. So everything's going to be taken care of. Now let's go back to this one over here. Now we don't have any extra junk up on top, so it kind of looks like this first one. Well, let's work at rewriting this. So I'm going to rewrite that as 1 over, I want something squared minus something squared, so I have 1 squared minus x squared dx. And when you just have a single x like that and a 1, you could apply the formula direct, but I'm just showing you the complete process. Okay, so that gives us negative 5/2, and then this becomes 1 over square root of u du. Okay, over to here, a would be 1, u would be x, and du would be dx. So that's going to replace that. The x dx dx. I shouldn't have used u's. Let me get rid of those. Let me choose w's. Oops. Wrong color. So that's w, and this would be dw. Why did I do that? because we already got u's here, so I don't want to confuse the issue. So then this becomes minus 1 over square root of a squared minus u squared du, because everything's accounted for. Okay, well, back to this one. We got negative 5 halves, and this becomes 1 over u to the 1 half. We want to get rid of the square root. Minus, and what did I put u there for? Losing my mind. It should be w, because that's what we said this was. And then this would be dw. I get so used to thinking the u-substitution. Well, this matches our formula exactly, except for a different variable, but still the same idea. So it matches our first one, which we rewrite as arc sine. So minus arc sine of u over a, so I'd have w over a plus c. Okay, so this gives us negative 5 halves, and this becomes u to the negative 1 half du. When you got a u to a power down below, you can take it and move it up on top, and the sign of the exponent changes. Now here we want to plug in what we have above. W we said was x, a was 1, plus c. Now back to our first integral here. We're going to add 1 to our power, so we got u to the negative 1 half plus 1 over, and divide by our new power, minus arc sine of x plus c. Okay, so we got negative 5 halves times negative 1 half plus 1 gives us 1 half over 1 half minus arc sine of x plus c. If you got a single fraction down your denominator, you can flip it and multiply it times your top part, so the 1 half becomes 2 over 1 times u to the 1 half minus arc sine of x plus c. Those 2's would cancel, and I have negative 5, and the square root, u to the 1 half is the square root of u, minus arc sine x plus c. Now we're so far down in the process, I've forgotten what u is equal to. So let me scroll back up and take a look. What did we say u was? U was 1 minus x squared. So I'll plug that back in now. So 1 minus x squared minus arc sine of x plus c. And that's our answer. Let me go ahead and save this. And let's look at our next problem. Got the integral of x minus 5 over x plus 2 squared plus 3 dx. Well, if we go back up and look at our formulas. Of course, there's no square root in it, so it has to be the middle one. A squared plus u squared, well, that'd be easy enough to rewrite in that form. We had to flip things around, but then we got some extra junk up on top. Well, let's think if we set the bottom part equal to u. So set the entire denominator equal to u, because that's one of our techniques. If you got a fraction, try to set u equal to all the bottom part. Du, the derivative of that, take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses, which is 1. And the 3 drops away. Dx, which means we'd have du is equal to 2x plus 4. Dx. We don't have a 2x plus 4 up here. Well, we could probably get one. Let me put a 2 up there. So I'll put a 1/2 out in front. And I'll put a 2 up there. Dx. So then that gives us 1/2, and that gives us 2x minus 10 over x plus 2 squared plus 3. We're closer. We got our 2x there, but I need a plus 4. Well, let's rewrite this as 2x plus 4 minus 14. Now notice what I have up on top now. I have my 2x plus 4. If I were to go backwards, 4 minus 14 gives you your negative 10. So I haven't changed its value at all. I just changed the way it looks. So I got our 2x plus 4. So now I want to split this into separate integrals. And I got to leave the 1/2 out in front of each one. So this one will be 2x plus 4 over x plus 2 squared plus 3 dx minus 1/2 the integral of 14 over x plus 2 squared plus 3 dx. Well, the first one works real well with our U-substitution we were proposing up above, because everything matches. We got our 2x plus 4, we got our dx, 2x plus 4 dx, and this is u, so that works perfect. And now looking at our second integral, we have something squared plus something squared, and there's nothing up on top. Well, we got a 14, but we can take that and put that out in front. So everything looks like it's going to work out really nice. Okay, so for this one, u is going to equal to x plus 2 squared plus 3. And the derivative of that we already set up above. Take your power, put it out in front. That gives us 2x plus 4 dx. So all that is accounted for with that. 2x plus 4 dx, 2x plus 4 dx, that's going to be replaced by du. So we got 1/2, and this becomes 1 over u du. Now let's look at our second part here. The 14, that's extra junk. We'll put it out in front. So we got minus 1/2 times 14. And my formula says we got a squared plus u squared. Well, addition's commutative, so it doesn't really matter. I can flip those around if I want. Rewriting the 3 as something squared, we're going to have the square root of 3 squared plus x plus 2 squared dx. Well, I'm going to do a substitution over here too. Our a is going to be square root of 3, and I'll choose w. So I'll let w is equal to x plus 2 dw. The derivative of x plus 2 is 1, so 1 dx is just dx. So that's accounted for right there. X plus 2, dx, dx. So everything's accounted for. So let's continue this. So we've got 1/2. The integral of 1 over u is natural log of the absolute value of u. 1/2 times 14 is 7. And then this becomes 1 over a squared plus u squared du. So we got 1/2 natural log, and what was u? U we said was x plus 2 squared plus 3. X plus 2 squared plus 3. So we're going to have natural log of x plus 2 squared plus 3 minus 7, and this matches our formula exactly. Integral of 1 over a squared plus u squared, so that becomes 1 over a arctangent of u over a plus c. Well, in this part, x plus 2 squared, that's positive. Plus 3 is still positive, so those absolute value bars aren't necessary. So you could put parentheses there if you want. And this would be x plus 2 squared plus 3 minus 7 over, or 7 times 1 over square root of 3. Plug everything back in. And what did I put u there? Boy, I'm just really stuck on u's. We did a w substitution there. So that's w, this is dw, this would be w. Okay. So then w we said was x plus 2 over a, which was square root of 3, plus c. And that's basically our answer. We could put the 7 over square root of 3. You could multiply the top and bottom by square root of 3 if you want to get rid of that. But go ahead and save that. Problem was that? Number 9. Okay. So let's look at problem number 10. This is wanting us to evaluate the integral. So a definite integral. We're going from 0 to 2 of dx square root of 9 minus x squared. Okay, well, let's go back up to our formula. We've got a square root downstairs, and you have a number before the minus, the 9 minus. So it's going to be the a squared minus, because it's the number before the minus. So our first formula is what we want it to look like. Well, we want to rewrite it as something squared minus something squared. So we got 3 squared minus x squared. So our a is going to be 3. Our u will be x, and du would be dx. And everything's counted for. So this becomes, and I'm going to put x values here. This is from x equals 0 to x equals 2. And this is 1 over square root of a squared minus u squared du, which matches our formula exactly. So we're going to rewrite that as arcsine. So this will be arcsine of u over a from x equals 0 to x equals 2. We want to plug our u and a back in. So we're going to have arcsine of u, which was x, over a, which is 3, from x equals 0 to x equals 2. Now if I plug in these values, I'm going to have arcsine of 2/3 minus arcsine of 0 over 3, which gives us arcsine of 2/3 minus arcsine of 0. Now if you remember working with these back in trig, if we set that equal to a variable like p, we got p is equal to arcsine of 0. If we go ahead and take sine of both sides, so we got sine p is equal to sine of arcsine of 0, we end up with sine of p is equal to sine and arcsine cancel, we get as equal to 0. Now if you think about where arcsine is valid, that's valid from negative pi over 2 to positive pi over 2. And if I think where sine is equal to 0 at, well, sine is equal to 0 here at 0. So that would tell us that this becomes arcsine of 2/3 minus 0, which just gives us arcsine of 2/3. And that's our answer. Now, when I said it's equal to 0, that means we just found what p is. And p is what we said equal to arcsine up here. So let me go ahead and save that. That was problem number 10. So let's look at number 11. Another definite integral. And we got natural log of 3 and natural log of 5. 2e to the negative x over square root of 4 minus e to the negative 2x dx. Alright, let's go up to our formulas. First off, we got a square root downstairs, so you'd see the first one, the third one. Specifically, this one is like where you have a variable before the minus. This one's where you got a number before the minus, the a squared minus. Well, we got a number before the minus, so we're going to look at the first formula. Well, I want to rewrite that as something squared minus something else squared. So this is going to be the square root of 2 squared minus, and I want this to be something squared, and this would be e to the negative x dx. Because think of it going backwards. If you raise one exponent to another exponent, you multiply the exponents. Negative x times 2 would give you your negative 2x. Now, a would be 2, u would be e to the negative x, du. The derivative of e to the negative x is e to the negative x times the derivative of the exponent. Well, the derivative of negative x is negative 1, and then dx. Which works out fairly well because we have the e to the negative x up there, but we don't have a negative 1. And we also have an extra number we don't need. So again, I can throw the 2 out in front. And we need a negative up there, so I'll put a negative up there. And then this is 2 squared minus e to the negative x squared dx. Now to counter this negative I put up on top, I'm going to put a negative 1 out in front. Because a negative 1 times a negative gives us positive. Okay, now let's see. That's going to account for that. E to the negative x, e to the negative x. Negative e to the negative x, negative e to the negative x, dx, dx. So everything's accounted for. Now 2 times negative 1 is negative 2. And I'm going to put x values here. So this is x is equal to natural log of 3. And this is x is equal to natural log of 5. And then this becomes 1 over the square root of a squared minus u squared du. Which matches our formula exactly. Which one is it? This is first one. So I'll make that as arc sine of u over a from x is equal to natural log of 3 to x is equal to natural log of 5. Well, let's plug our values back in. We said u was e to the negative x, so we're going to have arc sine of e to the negative x over a, which was 2, from x is equal to natural log of 3 to x is equal to natural log of 5. Well, we'll plug those values in now. So we're going to have arc sine of 1/2 e, and then I'll plug in the natural log of 5 for the x. So I got e to the negative natural log of 5 minus arc sine of 1/2 e to the negative natural log of 3. Okay, so this becomes arc sine of 1/2 e to the natural log of 5 to the negative 1 power. If you got a number out in front of your log, you can put as your power. So I took this negative 1 that's in front of our natural log and put as our power. Minus arc sine of 1/2 e, and I'll do the same thing here. So this becomes 3 to the negative 1. Now, if you remember from college algebra, if you have e to the natural log, they're going to cancel each other out. So we're going to have negative 2 arc sine of 1/2 times 5 to the negative 1 minus arc sine of 1/2 times 3 to the negative 1. Well, 5 to the negative 1 is 1/5. And 3 to the negative 1 is 1/3. So this is going to give us negative 2 arc sine of 1/10 minus arc sine of 1/6. I can multiply the negative 2 through, but that's basically our answer. So we go ahead and save that. And that was problem number 11. Okay, let's look at number 12. And let me grab a drink. Okay, so we got 2x minus 1 over x squared plus 4x plus 5 dx. Look at my formulas. We got the square roots downstairs, can't be those, so it has to be the middle one. But we got extra junk up on top. Well, we saw this earlier. Remember, if I let u equal to the denominator, u is equal to x squared plus 4x plus 5, du would be 2x plus 4 dx. Which is close. We got to 2x, so we can rewrite the top as 2x plus 4 minus 5 over x squared plus 4x plus 5 dx. Because going backwards, 4 minus 5 would give us a negative 1. And now we have our 2x plus 4. So I must put this into separate integrals. So I got 2x plus 4 over x squared plus 4x plus 5 dx minus, and then I'll put the 5 over x squared plus 4x plus 5 dx. First one is pretty straightforward. We let u equal to the denominator. U is equal to x squared plus 4x plus 5. Du, the derivative of that, would give us 2x plus 4. And remember, we throw on a dx. So this is accounted for. 2x plus 4, 2x plus 4, dx, dx. So everything's accounted for. So this is going to become 1 over u du. Now this right here, we need it as in this form. Well, how we can get that is with completing a square. Now if you remember completing a square, we take the number that's before our x, which is 4. Take, and the 4 I'm talking about is 1 right here. Take it times a half and you square it. Well, 4 times a half is 2. 2 squared gives us 4. So this becomes 5 over x squared plus 4x plus 4. And we're going to do a minus 4 right beside it. And then the plus 5 carries along. So again, what I did is I took the number before the x, which is a 4, multiplied it times a half, squared it, and that gave us 4. And then I added 4 right next to it, and then I did a minus 4. Because if I were to go backwards, 4 minus 4 cancels. Now specifically, we're going to group these two together, and then we're going to group, or these 3 together, and then we'll group these 2 together. Well, let's go back to our first integral. The integral of 1 over u is natural log of the absolute value of u minus, and I'm going to take that 5 and put it out in front. I know I'm not going to need it. 1 over, and this factors as x plus 2 squared, and negative 4 plus 5 gives us 1. And that's looking close. We can easily rewrite that as something squared plus something squared. Now if you remember the trick from college algebra, whatever number's right here, right before you squared, is always what goes right here. So it makes that factoring very easy. Well, let me plug my u back in. What did we say u was? U was x squared. So we've got natural log of the absolute value of x squared plus 4x plus 5 minus 5. What goes first? The a goes first. So let me rewrite this. I'm going to put the 1 first, and we want to rewrite it as something squared. So we got 1 squared plus x plus 2 squared dx. And now we're ready to do our u substitution. Since I already plugged this u back in, I'll go ahead and use u. So a is 1, u is equal to x plus 2, du, the derivative of x plus 2 is 1, and 1 dx is just dx. So that accounts for that. X plus 2, dx, dx. Okay, so we got natural log of the absolute value of x squared plus 4x plus 5 minus 5, integral of 1 over a squared plus u squared du. Just plugging everything in. That gives us natural log of the absolute value of x squared plus 4x plus 5 minus 5 times, matches this formula directly, so we're going to rewrite that as 1 over a, arctangent of u over a. I'll put my plus c in now. So we got natural log of the absolute value of x squared plus 4x plus 5 minus 5 times 1 over a, so 1 over 1, arctangent u, which was x plus 2, over 1, plus c. Which, simplifying that, we got natural log of the absolute value of x squared plus 4x plus 5. 1 over 1 dropped away, so we got minus 5 arctangent of x plus 2 plus c. And that's our answer. So let me go ahead and save that. And let's look at number 13. This is another complete and a square one. So we've got the integral of 5 over the square root of negative x squared plus 6x dx. Well, we need to complete the square, what's inside the square root, to see what pops out. We want it to either look like our first one or our last one, so it's going to be one of those. Now, it's hard to complete the square when you have a negative there. So I'm going to bring that, factor that negative out. So that gives us x squared minus 6x when I factor out the negative 1. And we're going to complete the square on what's inside the parentheses. So again, you take the number that's before your x, which is negative 6, you multiply it times a half, and you square it. Negative 6 times a half is negative 3, negative 3 squared is 9. So we're going to have a negative, and then inside of parentheses we have x squared minus 6x plus 9 minus 9. You always immediately, when you add the 9, you put a minus 9 beside it. If it's going backwards, they would cancel, wouldn't they? Now specifically, we want to group these together and this one by itself. So we've got square root of negative, and I'll put a bracket here. The negative affects everything. This one factors as x minus 3 squared. Then the minus 9 dx. Again, remember the little trick for that. Whatever number's right here, right before you squared, is always what goes right here. Makes that step so easy. Well, now we have a negative out in front, so I'm going to take that and multiply it times the x minus 3 squared and times the negative 9. Now I'm going to go ahead and take the 5 out front. I know I'm not going to need it. 1 over, and then this would give us negative x minus 3 squared. Negative 1 times negative 9 gives us a positive 9 dx. Now I can flip those two around. So this is going to become 1 over the square root of 9 minus x minus 3 squared dx. And that's looking good, because we can rewrite that as a squared minus u squared. So let's go ahead and rewrite that as something squared minus something else squared. So the 9 I can rewrite as 3 squared minus x minus 3 squared dx. Okay, a would be 3, u would be x minus 3, du. The derivative of x minus 3 is 1, and then we put on a dx, so that just gives us dx. So that's going to replace that. The x minus 3, dx, dx. So everything's accounted for. So this becomes 1 over the square root of a squared minus u squared du, which matches our formula exactly. So we're going to rewrite that as arc sine of u over a plus c. Okay, so we got 5 arc sine. U we said was x minus 3 over a, which is 3, plus c. And that's our answer. So let me go ahead and save that. That was number 13. So let's go take a look at 14. Now sometimes I'll dive right in with the problem without really just analyzing the problem. Like right away I look at this and I come up here and I say, okay, obviously it's one of those ones with square root downstairs, and obviously we're going to have to use completeness square because we got an x squared minus 8x. And then I maybe dive right in, do 5 or 6 steps, and realize, whoa, this isn't working out quite like I think. Remember our first basic rule of the U-substitution, besides if you got parentheses to a power, you let u equal to what's inside of parentheses. If you got a radical, try to let u equal to what's inside a radical. So let's do that first. U is equal to x squared minus 8x. Derivative of that, that would give us 2x minus 8 dx. And I notice these both have a 2 in common, so I can factor that out. And all of a sudden, it's starting to look like the top part. I just need a 2 up there. So I'll put a 2 up on top. And we offset it by putting a 1/2 out in front. And now, everything matches. X squared minus 8x, x squared minus 8x. 2x minus 4 dx, 2x minus 4 dx. So everything's counted for, so this becomes 1/2 integral of 1 over the square root of u du, which we can rewrite the square root of u as u to the 1/2 du. And we can take that u to the 1/2 up on top, becomes u to the negative 1/2 du. Now take an integral of that. We'll add 1 to our power, divide by our new power, plus c. Now negative 1/2 plus 1 gives us positive 1/2. Now notice something here. I got 1/2 here, I got 1/2 in my denominator. Those are going to cancel. And we got u to the 1/2 plus c. U to the 1/2 is the square root of u plus c. And now we're ready to plug u back in, whatever we said u was. U we said was x squared minus 8x. So I got x squared minus 8x plus c. And that's our answer. So let me go ahead and save that. probably should have jotted down which one I was working on. I guess it was that one. So let's look at number 15. So we got the integral of x over square root of 4 plus 10x squared minus x to the fourth dx. If I let u equal to what's inside the square root, du would not equal to the top part. So I know that's not going to work. Now I can flip those around, put the negative x to the fourth here, plus 10x squared, and then plus 4 here. And I want to complete the square on this. Again, I'm not very successful if I leave the negative in there, so I'm going to factor out the negative 1. And that leaves us x to the fourth minus 10x squared minus 4 dx. Well, with completing the square, the fact that this is x to the fourth, x squared, no x, this is still quadratic in form, but doesn't change anything. We take our number before x, which is negative, or before x squared, which is negative 10, multiply times a half and squared. Negative 10 times a half is negative 5, negative 5 squared is 25. Okay, so this is going to become negative x to the fourth minus 10x squared plus 25, the number we just found, and then minus 25, minus 4 dx. Specifically, we're grouping these first three terms together and these last two numbers together. Okay. So then this becomes x over the square root of negative, and I can factor this. This factors as x squared minus 5 squared. It's same idea as before. We take whatever number's here in the parentheses right before you squared, which is negative 5, and put it here. But instead of there being an x here, we have an x squared. And I need a bracket here. This negative is on the flip side of everything. And negative 25 and negative 4 is negative 29 dx. Okay, we're going to take this negative and multiply it times the x squared minus 5 squared and times the negative 29. And I'll also flip it around in the same step. So this will become the square root of positive 29, negative times the negative 29, and then minus x squared minus 5 squared dx. Well, now we have, come up here, square root downstairs, we've got a number before the minus. Number before the minus is our first one. So we're going to rewrite that as something squared minus something else squared. So this becomes x over the square root, and I can rewrite the 29 as the square root of 29 squared minus x squared minus 5 squared dx. Well, a would be square root of 29, u would be x squared minus 5, du, the derivative of x squared minus 5 is 2x dx, which works out well because we have an x up on top. But we don't have the 2, so we'll put a 1/2 out in front, and we'll put a 2 up on top. So now, let's see what's accounted for. Square root of 29, square root of 29. X squared minus 5, x squared minus 5. 2x dx, 2x dx. So everything's accounted for. So this becomes 1/2 the integral of 1 over the square root of a squared minus u squared du. Which matches our formula exactly, the first one. So I'm going to write that as arc sine of u over a plus c. So we've got 1/2 arc sine, u was x squared minus 5, over a, which was square root of 29, plus c. And that's our answer. So go ahead and save that. And let's look at our next problem. Guess this is one. This is just kind of a weird problem. If they didn't give the hint, I would struggle with myself with this problem. It'd take me a while. Okay, it says use the specified substitution to find or evaluate the integral. So they're telling you to let u equal to the square root of x minus 4. Well, that's going to account for the top part here, so that's going to disappear. Well, u is equal to x minus 4 to the 1/2. That's what square root means. Now let's see what du is equal to. We got 1/2 x minus 4 to the negative 1/2 dx, which gives us 1 over 2 times x minus 4 to the 1/2 dx, which gives us 1 over 2 square root of x minus 4 dx. Okay, well, let's see what in the world we have. We got our x minus 4 up on top. We've already accounted for that, so that's gone. Okay, now what we need is we need a 2 down below. That's easy. We put a 2 down here, we offset it with a 2 out in front, because putting a 2 in the denominator is like 1/2. 2 times 1/2 would be accounted for. Now we also need a square root of x minus 4 downstairs. Now to account for that, if you put a variable of some form down your denominator, you have to put it up on top also. Okay, and then dx. Well, this right here, the 2 square root of x minus 4 down denominator, is going to take care of that. The dx is going to take care of that. So everything's handled with du. Now we got an extra square root of x minus 4 up here, which is not an issue, because we know what square root of x minus 4 is. It's equal to u, so that's going to be accounted for by that. Okay. Now we have another item down that I didn't write down yet, the x plus 2. Okay, so how in the world do we account for this? If I go back up to my u-substitution here, if I square both sides, I would get u squared is equal to x minus 4. If I take the negative 4 over to the left side, we get u squared plus 4 is equal to x. So as bizarre as it seems, we now know what x is equal to. X is equal to u squared plus 4. So this x right here is going to be handled by that. Okay, now let's plug in everything, see what we got. We said the red is our u, so this is u times u up on top. The green, 2 square root of x minus 4 and dx, that's just going to be replaced by du. And this x, we said, is u squared plus 4. So that becomes u squared plus 4, and then the plus 2 carries down. Okay, so let's see what we have then. U times u is u squared, and we have u squared plus 6 du. Remember earlier, I said if your degree of the top is greater than or equal to the bottom, then you use long division. And that's what we'll do here. So I got u squared plus 6, and I'm going to divide it into the top part, which is u squared. You look at the first term of each, decide what to put up on top. You ask yourself what times u squared gives you u squared, and that'd be 1. Now 1 times u squared is u squared, 1 times 6 is 6. And remember, we're going to subtract this line, so that becomes a negative, this becomes a negative, so we got minus 6. So we can rewrite this as the integral of 1 minus 6 over u squared plus 6. du. Well, I can split these into separate integrals, and as I do that, I have to keep this 2 in front of each one. So I got 1 du minus 2, and then 6 over u squared plus 6 du. First one's pretty easy. Integral of 1 is u, so this is 2u. I'll put the plus c on later. Now I'm going to take this 6 and put it out in front because I don't think I'll need it. And here we got u squared plus 6. I want to rewrite that as a squared plus u squared. So I'll flip these around and put the 6 first. And I want to write it as something squared. So I got square root of 6 squared plus u squared. And this 1 here, because I took 6 out in front, du. So I got 2u minus 2 times 6 is 12. And a is square root of 6. So this becomes the integral of 1 over a squared plus u squared du. Which happens to match our formula exactly. So we got 2u minus 12 times 1 over a arctangent of u over a, and now I'll put my plus c in there. Well, let's plug everything back in. I've forgotten what u was. If I go clear up here, u is equal to square root of x minus 4. So put in square root of x minus 4 for the u, minus 12 times 1 over a, and a was square root of 6, arctangent of u, which was square root of x minus 4, over a, which was square root of 6, plus c. Now I could multiply the top and bottom by square root of 6, get rid of that down denominator, but that's basically our answer. Okay, so that's 12. What problem was that? That's 15. So let's take a look at 16. Got the integral of 1 over 7 square root of 5 minus x, square root of x plus 2, dx, and they tell us to let u equal to square root of x plus 2. Okay, well right away this is going to be taken care of by that. So that's pretty obvious. Now this is also equal to x plus 2 to the 1/2. So du, take a power, put it out in front, what's inside the parentheses remains as is, lower your power by 1, and then I put on dx. Now we'd multiply times the derivative of what's inside the parentheses, but derivative of x plus 2 is 1. So this gives us du is equal to 1 over 2 times x plus 2 to the 1/2 dx, which is 1 over 2 square root of x plus 2 dx. Okay, so let's see what in the world we're dealing with. It doesn't look like I have any 7s over here, so that 7 I'm going to go ahead and throw out in front. And okay, so we said that this is handled, so we're fine there. That's going to be handled by that. Now our du. We need a 2 downstairs. Well, that's easy. I'll put a 2 down there. And we offset it. 2 down denominator means like 1/2, so we put a 2 out in front. So that's taken care of. We also need a square root of x plus 2 down there. Well, that's easy. I'll put 1 down there. But remember, if you put x of any form down here, you have to put the same thing up on top. Okay, well, 2 square root of x plus 2, 2 square root of x plus 2. I didn't write my dx down, but and then dx, dx. So du is accounted for. So everything's good. We got an extra square root of x plus 2 up on top, but that's okay, because u is equal to that, so that's going to account for that. The only thing that's left to worry about is this square root of 5 minus x. Well, if I come back to this u is equal to square root of x plus 2, if I square both sides, I get u squared is equal to x plus 2. Take the 2 over, and I get u squared minus 2 is equal to x. So now we know what this x is. That's equal to u squared minus 2. So let's do our substitutions. 1/7 times 2 is 2/7. This we said was u, so put that up on top. 2 square root of x plus 2 dx, that gets replaced by du. Now this gets replaced by u. So put a u down here. And now we got square root of 5 minus, and x we said was x squared minus 2. So I'll put parentheses and I'll put x squared minus 2. X squared, where'd that come from? U squared minus 2. So again, I just replace this x here with u squared minus 2. Okay, well this kind of works out nice. You notice the u's cancel, and I'm going to have 1 over, and I can rewrite the 5 as the square root of 5 squared minus can't read my own writing. Is that u squared minus 2? I'm all messed up. About time to go to bed, I guess. Okay, let's try it again. So that's 5, and this negative flips the sign everything, so it becomes a negative u squared plus 2 du. Which gives us, I tried to jump the gun on that one, 5 plus 2 is 7, so we're going to have 7 minus u squared du. Okay, now I can rewrite that. So I'm going to rewrite this as square root, and then we can rewrite 7 as the square root of 7 to the second power minus u squared du. Well, if I let a is equal to square root of 7, then what this becomes is 2/7, then the integral of 1 over the square root of a squared minus u squared du, which matches our first formula here. So I got 2/7 arc sine of u over a plus c. So I got 2/7 arc sine. I have no clue what u is. Let me go scroll to the top. U was square root of x plus 2. So I got square root of x plus 2 over a, and a was square root of 7 plus c. And that's our answer. So let me go ahead and save that. And let's look at our last problem. This is finding area of a region. Now notice in this picture, the area we're trying to find, this light blue, is above our x-axis, which means we don't have to worry about things being below the x-axis and whether you put a negative before it or so forth. We just do our setup just like normal. Well, this is going from -2 to 0 for our x values. So we got x is equal to -2 to x is equal to 0 of this. So we got 3 over x squared plus 2x plus 8 dx. Well, we only have 3 formulas, and it obviously doesn't have a square root in the denominator, so we're going to try to rewrite it this way. And we need to use complete the square to do that. So we got x is equal to -2 to x is equal to 0. The 3 I can go ahead and put out in front. I know I don't need that. So 1 over. Remember, you take what's before your x, which is 2. You multiply it times a half and you square it. 2 times a half is 1. 1 squared is 1. So we're going to have x squared plus 2x plus 1 minus 1 plus 8. And again, we're grouping the first 3 terms together, and then we're grouping these 2 numbers together. Now, I always, when I come up with this number, I just do a plus 1 minus 1, or plus the number minus the number automatically. Some people like to just rewrite the 8 as plus 1 plus 7, and that's fine. I just find this way a lot easier to work problems. Okay, so this becomes first part factors as x plus 1 squared, and -1 plus 8 gives us plus 7 dx. Now we're trying to get it to look like this. We want the a first, so I'm going to flip those around, and I want to write it as something squared. So we got x is equal to -2 to x is equal to 0, 1 over, and I can rewrite 7 as the square root of 7 to the second power, plus x plus 1 squared dx. So our a is going to be square root of 7, u is going to be x plus 1, du, the derivative of x plus 1 is 1 dx, or just dx. And now that's accounted by that. X plus 1 dx dx. So everything's accounted for. So this becomes 3, and then integral from x equals -2 to x equals 0, and this is 1 over a squared plus u squared du, which matches our formula exactly. So it becomes 1 over a arctangent of u over a from x is equal to -2 to x is equal to 0. Now plug things back in. So this becomes 1 over a, so 1 over square root of 7. Arctangent of u, which was x plus 1, over a, which was square root of 7, from x equals -2 to x equals 0. Now the 1 over square root of 7 I can put out in front. So we got 3 over square root of 7. And I'll plug these values in for x. So we're going to have arctangent of 0 plus 1 over square root of 7 minus arctangent. Now plug -2 in for x. So we got -2 plus 1 over square root of 7. So we got 3 square root of 7. 0 plus 1 is 1, so we got 1 over square root of 7 minus arctangent -2 plus 1 is -1 over square root of 7. And if I wanted to, I could get rid of the square root of 7's downstairs. I'm not sure if it really adds anything to do that. But if we did, just so you see one problem I do that on, that's 3 square root of 7 over 7 times arctangent of square root of 7 over 7 minus arctangent of negative square root of 7 over 7. And that's our answer. So I'll go ahead and save that. And that's the end of our section, so let me go ahead and